This section is about linear equations. So a linear equation is basically just a straight line. You could think of it as a polynomial of degree 1, but it's kind of separate, so it's going to have its own section. There's a lot more we can talk about with linear equations. So I think the most known equation is y equals mx plus b. This one is very useful for finding an equation of a straight line. But there are other equations you definitely are going to want to know as well. Y equals y naught plus m times x minus x naught. That's an equation that I think you'll want to know for calculus. And also m equals y2 minus y1 over x2 minus x1. So these three equations will definitely be needed in calculus, especially early on in calculus. You'll be doing a lot of this, like a lot of this. It comes up a lot. I can't say that word enough. So how can we actually use these equations? Let's start off with an example. So let's find an equation of a straight line that goes through the point 2, 4 and has a slope of 5. Okay, we want to find an equation that goes through this point and has that slope. We could graph it just to kind of see what's going on. 2, 4, that's at 2, 4, so like right here, and it has a slope of 5, something like that, right? But what's the equation? Now, this first one is often called slope-intercept form. It's very useful if you know the slope and the intercept, which we do not here, right? We know the slope, but we don't know the intercept, so I would not use this equation. This second equation is called point-slope form because it's great if you know a point and you know the slope. Well, hey, we know a point and we know a slope. So this equation is what we want to use. So y naught means the y value of the point and x naught means the x value of the point. So we can just plug it all in. Y equals y naught, well, that's 4. That's the y value of the point, right? It's the second value in there. Plus m, which is 5. They directly told us that. M is the slope. Times x minus x naught, which is 2. We're done. I would say, and most of the time in calculus they say the same thing, but usually you don't have to simplify because it can get complicated if you simplify. So I would just turn this in and say, hey, that is my answer. However, if you're asked to simplify, all you have to do is distribute the 5 to get 4 plus 5x minus 10. That's the 5 times negative 2 is to negative 10. And then combine to get 5x minus 6. 4 minus 10 is 6, negative 6. So 5x minus 6 is the same thing. All we did when we simplified is we took this equation that was in point-slope form and we converted to slope-intercept form. But they're both equally correct. Do whichever one you want to do, unless your teacher tells you otherwise. They mean the same thing. Okay, let's take a look at another one. Here, we're going to ask for the same thing. Find the equation of a straight line that has a y-intercept this time of 2 and a slope of negative 2. Well, in this case, we were told the y-intercept and the slope. So that makes sense to use the slope-intercept form. So I'm just going to say y equals the slope, that's negative 2 times x, plus b. Well, it was fast and easy, right? If you graph this, it has an intercept at 2 and it has a slope of 1. There's the equation of that line. All right, let's do another one. So again, we want to find an equation of a line, but this time we want to find one that goes through these 2 points, 1, 3 and 2, 4. Now, if I look at these options here, this one is only good if we know the intercept. So I'm not going to want to use that, right? This one is only good if we know the slope and a point. Well, we only know 2 points, but we don't know the slope. Well, luckily, we have another equation. If you have 2 points, you can find the slope. So after a bit of calculation, we will know the slope. So we're going to then still use the green equation, which is the point-slope form. But first, we need to find the slope. Now, the y2 minus y1 over x2 minus x1, I think of it as just change in y over change in x. So what I like to do is I'm going to label this 0.1 and I'm going to label this 0.2. It really doesn't matter which one you do. If you label the first one 0.2 and the second one 0.1, you'll get the same answer, which is kind of interesting. But y2 is just going to be the y value that is on 0.2, so 4. And y1 is going to be the y value on point 1, so 3. And then we'll divide by, same idea for x. We have x2, which is 2, minus x1, which is 1. So then that's 4 minus 3 is 1 over 1. So the slope is 1. Now, I mentioned earlier that you can do it the other way around. What if we did that? What if we swap P2 and P1? If we did, then we would have 3 for the y2 minus 4 over 1 minus 2. We would just flip everything. But then we would get negative 1 over negative 1, which is still 1. So that's why it doesn't matter. However, I want to point out, and this is something people miss a lot, so be careful. You have to keep it straight. What would be wrong is if you flipped part of a point. Like if I did 3 minus 4 divided by 2 minus 1, that would be I flipped the x's but not the y's. I didn't keep it straight. So this is going to be negative 1, which is wrong. Don't do that. So label your P1 and P2 and then keep it straight from there. But it really doesn't matter which one you choose. Okay? So let's back up to where we have the slope. We don't have to compute it multiple ways. We know the slope is 1. So now we know a point, actually 2 of them, and the slope. So I'm going to say y equals y naught. That's the y value of a point. Well, which one do you want to use? It doesn't matter. You can use P1 or P2. You pick. I'm going to choose the one with the smaller numbers. I'm going to use P1 here. So y naught is 3 plus m, we calculated that is 1, times x minus x naught. So again, like I said before, I would just say, hey, that's my solution. However, if you want to simplify, that's fine. We distribute the 1, which really means just drop it. So 3 plus x minus 1. So that becomes x plus 2. Same equation, same answer. All right, let's do another problem. So here, we want to do basically the same thing. But we want to find an equation of a line through negative 1 comma 2 that is parallel to the line y equals 2x plus 6. So this means we have to know what parallel means. And I want to point out that this problem right here is exactly the problem you definitely need to know before you take calculus. You will be answering questions very, very similar to this, just with a calculus spin on it. So what we need to do is first note, what does parallel mean? It means the same slope. That's what parallel means. It will have the same slope as this line here. Well, if you look at this line, it's in mx plus b form, so the slope is 2. So when I said parallel to y equals 2x plus 6, that means the same thing as saying the slope is 2. So we know how to do this from earlier. It's the same problem we did over here. We'll use this equation. We have y equals y naught, that is the 2 value here, plus m, which we found to be 2 from the slope here, times x minus x naught. Minus a negative means plus 1. And I'm done. Although, if you want to, we can simplify. 2 plus 2x plus 2 is 2x plus 4. That's it. So there's one more example that I do want to point out that they can do that you should know about. And that's going to be, instead of parallel, let's say it said perpendicular. I don't know how to spell it. I'll just call it perp. So find an equation of a line that's perpendicular. Well, this would be a little bit different because what we would do is do negative 1 over the original slope. A perpendicular line has a slope that is negative 1 over the slope of the other one. So the slope would be negative 1/2. Otherwise, it's the same thing. We'd still have y equals y naught is still 2, plus m, this time it's minus 1/2 times x plus 1. Nothing changed. I'll let you simplify that if you'd like. I'm not going to bother because, like I said, I think that is the correct answer. It doesn't need simplified any further. So now we know how to do linear equations.